Welcome, everyone. Welcome to this webinar introducing edition 2026 of the National Ecological Footprint and Biocapacity Accounts. This edition was co-authored by 10 researchers whose photos you could see at the top of this slide. All are based at either York University or the University of Iceland, working in partnership through the International Ecological Footprint Learning Lab, which is a project of the Ecological Footprint Initiative based at York University in Canada. Today, you'll hear from 6 of these researchers. You'll hear from Kiona Lo, Neha Basnet, Bumika Srikanthalingam, Johanna van Berkum, Petra Toneva, and myself, Eric Miller. Other co-authors of this edition are Beatrice Foley, Anna How Long, Marina Ermina, and Clara Klinkenberg. In today's webinar, you will hear us speaking about world results, biocapacity and ecological footprint, countries and how they compare from an ecological footprint and biocapacity perspective. You'll also hear us speak about commodities, which we find interesting, drawing from thousands of commodities which we track, highlighting just a few of interest. We'll also speak about improvements to the data that are integrated into this edition and how that compares to prior editions, which some of you might be familiar with. This is our 6th edition that we've produced within the last 6 years. We will also speak about accessing the data for it to be useful to you and your organizations, and how you can combine data of ecological footprint and biocapacity with other data sets of interest and of use to the world. The example we'll profile here of combining the data will be combining data about ecological footprint with data about life satisfaction of humans to better understand the extent to which trends in ecological footprint are relating to trends in life satisfaction or not on a national basis. And finally, you'll hear about our partnership, and we'll invite you and your organizations potentially to engage in our partnership if you feel that we have some common interests and you can help amplify a lot of this work. So let's start with a focus on the world, what some have called Spaceship Earth when viewed from this perspective. Another way we can visualize the world is in 2 dimensions, recognizing, though, that this distorts the apparent size of land at the poles, but it does allow us to see much more of the details there. This is an image from the European Union's Earth Observation Program called Copernicus. In our research, we are interested in the biological cover of the land and how humans use it. And so here's a way to visualize that in mutually exclusive categories. So the green-colored terrestrial areas on this map are forest land. Of course, these forests vary in their type across the planet. Yellow-colored areas are areas of grazing land. This is pasture that's suitable for grazing animals. Orange-colored areas are cropland, which humans use to grow annual or perennial crops. Gray-colored areas might be hard to see on this, but they are there, and they represent built-up land in our cities and of the infrastructure that connects our cities, etc. The lighter-colored blue on this map are fishing grounds. These are the areas off the continental shelf, as you could see, on the edges of the continents, which have the most marine life. In 2025, this is how that area sums up in terms of hectares. Our accounting focuses on 12 billion hectares, which are the most biologically productive. Now, if you're familiar with the Earth's geography, you'll probably know that the planet has many more billions of hectares. The area that's not represented in this stacked bar is mostly ocean that is not fishing grounds, which you can see in the visualization here as the part of the oceans which are much deeper blue, if not almost purple in color. In addition, there are about 6 billion hectares of land that is void of significant vegetation because, for example, it's desert or covered in glaciers, as you could see in the absence of a color here with white on the map. Now, in our accountings of the planet's land cover and land use, we make use of what we call biocapacity in terms of global hectares. So we make equivalents, the area in hectares, to global hectares based on the biological productivity of each hectare. On a global basis, then, you can see that each hectare of forested land or cropland provides more biological productivity than each hectare of grazing land or fishing grounds. Now, these statistics are all related to countries on the planet as they've evolved since 1961, with the borders on this map of in the more recent year. Now, this biocapacity then is of the planet is our quantification of the capacity of the lands and waters to support our ecological footprint as humans, which is also measured in terms of global hectares. And this is what the comparison looks like. Having an ecological footprint in global hectares allows us to make comparison with biocapacity in global hectares, and this allows us to make comparisons across space and over time. In 2025, humanity's ecological footprint exceeded 20 billion global hectares. It was in excess of the biocapacity of the planet, and that relates to the story of overshoot and with the accumulation of carbon dioxide in the atmosphere and the drawdown and pressures that humans have placed upon landscapes and ecosystems across this planet. Now, if you notice in the legend here, I've added some other components to represent the slightly different coloration on some of these components of the chart. So the black component of ecological footprint is the global hectares that are needed to absorb humanity's emissions of carbon dioxide after taking into account the sequestration of carbon in that same year by the world's oceans. And so that's represented as the forest carbon uptake component. Below that, the green component is the global hectares of forest products needed to support our production of lumber and paper and so on. Below those are the components that I spoke about before, the grazing land in yellow, which is the area of pasture that was needed to supplement any feed that was provided to grazing animals, feed being derived from the orange component there, which is cropland. And all those are stacked on top of the built-up land and fishing grounds component as well. We call this statistic ecological footprint of production because it relates to what humanity produced in that year. More than a quarter of all production was traded across national borders, and so we have that represented as the other series in the data. On the level of the aggregate of all of humanity, humanity's ecological footprint of production was consumed on the planet by other people, so the ecological footprint of consumption is the same as production. But as you'll see later on in this presentation, when we look at these results on a national basis, there can be differences, sometimes quite significant, between the ecological footprint associated with what was produced within a jurisdiction compared to what was consumed within a jurisdiction. So that's a bit of an overview as a starting point. One final point then is to know this is just the results for 2025, but we can look at a timeline of results. So here's the timeline from 1961 to 2025. The results of 2025 are the same results that I just showed on the prior screen. But in this case, we have divided the sum total of ecological footprint divided by biocapacity, with that horizontal red line as a ratio of 1, which then reveals for 2025 that ecological footprint was certainly over 70% greater than the capacity to be sustained on an ongoing basis by biocapacity. Our team integrated 91 million rows of input data to be able to derive statistics and charts such as this, and this with an ecological footprint of humanity from 1961 to 2025. As you can appreciate, the shape of this evolution has varied over time. It has tended to grow, although that growth has slowed, certainly in the last decade. And certainly there's much less growth more recently than there was in the earlier period of this timeline. You'll also notice along the timeline, there are a number of periods of inflection points or even declines in ecological footprint, which relate to all sorts of moments in the economic history, including, of course, at this time, the oil crisis in the 1970s. Then we have the savings and loans crisis that had quite a significant effect in the early 80s, late 70s. Then there was a dissolution of the former Soviet Union, the Asian financial crisis, dot-com bubble bursting, of course, the significant global financial crisis of 2008, 2007, 2009-ish, and then the Chinese stock market crash, and of course, more recently, the COVID-19 pandemic and its associated lockdowns. So this is a bit of a picture on a national basis. But of course, on a country-specific basis, there will be also a lot of variability, sometimes reflecting these events, sometimes reflecting other events that are more specific to that country of interest. And so in this realm, let's turn next to some focus on results at a country level.
Thanks, Eric. So Eric just went through the results at the global level. But now I'm going to zoom in onto the country level and look at how footprint is distributed across different countries and what tells us the story behind the raw numbers. So as Eric has mentioned, at the country level, we don't just look at footprint that is produced domestically, which is the footprint of production. We also consider trades to calculate the footprint of consumption. And on the supply side, we calculate each country's biocapacity, so the area of regenerative capacity within a nation's borders. We provide both metrics as the country total in global hectares, but also in per person average in global hectare per capita. So with this framing in place, we can look at the results in the year 2025. So in front of us here is the distribution of the national consumption footprint for 128 countries, which we report the consumption footprint, order from the largest to the smallest, from the top to bottom. And what you immediately notice is that it is highly skewed. We see that there's a long tail on the right, which represent a small cluster of countries with very large footprints, with the largest reaching above 1.8 billion global hectares. And then we have a large chunk of countries more kind of compressed towards the lower end on the left. Many countries with footprints smaller than 0.2 billion global hectares. So this is indicating that the demand on nature is highly concentrated in a handful of countries. So now we'll look at who these countries are and how do they rank in terms of total consumption footprint. So coming on top of the list, we have China. China is the world's third most populous country, and its consumption footprint as a nation total is nearly 5.5 billion global hectares. To visualize it, if the entire South America has the world's average productivity, China would need 3 times the area of South America to fulfill its consumption. So just this single country with roughly 1/6 of the global population is responsible for more than a quarter of the global demand on nature. And then moving on the third, we have India. So India is the world's most populous country, with also about 1/6 of the global population, but is only responsible for 8% of the global footprint. And then let's go back to the second, we have United States. United States with only around 4% of the world's population, but they're responsible for 12% of global demands of nature, with a triple its share in the world's populations. So this speaks to the high per person consumption average it has compared to the two on the list compared to China and India. And here are the rest of the countries that rank in the top 10 and other countries of interest. And I'll just note the ranking of Canada and Iceland, which is where our teams are based at. So Canada ranks 12, responsible for about 1.3% of the world's total, and Iceland ranks 99th with less than 0.1%. So overall, you can see here that the country rankings are dominated by population size, but although it's not perfectly ordered. So here we have the world's top 10 countries and their share of the world's total footprint. With some math, we can see how concentrated footprints are in the world in what kind of countries. So this next one here shows us that the top 4 countries, so we have China, United States, India, and Russia, together are responsible for half of the world's entire ecological footprint. So of the world's demand on nature. So these are the first 4 bars with the darker pink background at the very top. And to provide for reference, they account for just over 40% of the world's population. And then we extend that a little bit. We extend that to the next 19 countries. So a group that includes Brazil, Japan, Canada, and others. We account for an additional 25%. So in total, these countries represent 75% of the world's ecological footprint, just these 23 countries, but also keeping in mind that they also account for close to 70% of the world's population as well. And the remaining countries, which is 105 countries, shares the final quarters. So this here, it speaks to the level of concentration of our footprint. Again, the 23 countries on the top, it accounts for 75% of the world's global footprint compared to the 105 with the last quarter. So now let's shift our lenses. So these country totals tell us about the aggregate impact we have, but we can also look at the per capita figures, which tell us more about the lifestyle and consumption patterns. So here we have the distribution of national average ecological footprint per person in the year 2025. And the first thing you'll notice are the 2 countries in the upper end, Faroe Islands and Iceland. So these 2 countries are unique in their data set. About 70 to 90% of their footprints comes from fishing ground, which is the marine and inland waters required to sustainably support their aquatic harvest. Fishing ground, it requires a larger ocean area to produce a unit of yield compared to the rest of the components. And because Faroe Islands and Iceland have small populations, they have a small contribution to the world's total as well. We've provided more detail about this in our release notes for anyone who wants to look in a little bit deeper. And following Iceland on the ranking, we have Qatar at 11 global hectare per capita, and Luxembourg at 10 global hectare per capita. So it means that these 2 countries, each person on average, would require about 10 to 11 hectares of land with the world's average productivity to provide for their consumption in a single year. We know that both of these countries are among the wealthiest in the world. Qatar is driven by fossil fuels, and we know that both of them have high consumption, in particular, they have high emissions as well. And in order to looking at just the country ranking, when we look at their per capita, we also want to look at 2 key anchor points. So first, we have the dotted black line, which is the world's average footprint per person at 2.5 global hectare per capita in 2025. So when we compare this to the top 10 countries, we see that the top 10 countries are above the world's average, like United States and Canada, but we see that other G7 countries like France, Japan, and Germany are below this world average. And the second point that I want to mention, which is also very important, is that in order for us to live within the planetary's biocapacity at the current population level, which means there's no overshoot, our average per capita would have to come down to this dotted green line at 1.5 global hectare per capita, which is actually exactly the per capita average of Senegal. So right now, our average is at 2.5, but if we want to live with no overshoot, then our average would have to come down to this 1.5 global hectare per person. So this is all for the national consumption footprints. And this next, I want to turn to the supply side to look at biocapacity at the country level. So on the next slide here, we will see a similar pattern compared to the consumption footprint. So we see that biocapacity is also concentrated in a handful of countries. The main reason here being is largely geographic. Biocapacity also depends on the country size, the land cover type, and how productive their ecosystems are. And if we look at the ranking, you see that Brazil has the world's largest biocapacity in a country at approximately 1.7 billion global hectares, which, if you recall, is roughly equals to the total consumption footprint of India. More than 75% of Brazil's biocapacity comes from its forest areas, thanks to the Amazon rainforest. Next and second, we have the United States with 1.3 billion global hectares, slightly over 10% of the world's total. And we have the third, China, with around 1.1 billion global hectares. So both of their biocapacity are driven by their cropland and forest area. So looking through these country level pictures, we see both ecological demand and regenerative capacities are concentrated in a handful of countries, which are not necessarily the same, but we did see some overlap. In addition to this, we can also compare a country's total consumption footprint and its biocapacity to determine if a country can fulfill its own demand or it relies on other countries. So this part is where the trade component comes in. So now I will pass it on to Neha to talk about trades in terms of ecological footprint.
Thanks, Kiona. As we have seen from the previous presentation, footprint is not only tied to where production occurs, rather through the global supply chain. It can be embedded in traded goods and shift from producing countries to the consuming countries. So here we are looking at how much of the global footprint is produced in one country but consumed somewhere else. This is estimated using the larger value between global footprint of import and footprint of export relative to the global footprint of production. We use this approach because at the global scale, total production and total consumption balance out. But within that global total, countries are constantly exchanging goods and services. This graph shows us what share of world's production footprint crosses border before it's finally consumed. And what we see is a long-term increase. In the early 1960s, only around 12 to 13% of the global production was consumed abroad, as most production was linked to domestic consumption. However, this share increased precisely from 2012 onward, and it has reached to 30% or nearly one-third of the global production footprint. This means that the geography of consumption had changed. A growing share of consumption now depends on the footprint embedded in production outside the consuming countries. Any dips in the line can be interpreted as a moment when global trade slowed relative to production. And these dips also coincide with the major events as presented before. For example, in 1998, when there was Asian financial crisis, and in 2009, when world was recovering from the recession. Interestingly, footprint embedded with the global trade didn't decline during pandemic. However, in the later year, there is a slight decline. However, the overall trend shows increase. I think it's safe to say that footprint has become much more globalized. So after looking at the global trade, we bring the analysis down to the country level. The global trend tells us that footprint is crossing borders. But now we can ask which countries are on each side of that exchange. This graph shows the 2025 country level balance between net footprint importers and the net footprint exporters. The graph compares each country's footprint of consumption with its footprint of production, and the difference tells us whether the country is on balance or is drawing footprint from abroad or supplying footprint to the other countries. In 2025, 80% of countries in our account were the net importers, while only 20% of the countries were net exporters. So majority of countries in 2025 offshored their footprint. Countries on the right side of the graph also represented by the blue bar, are the net footprint importers, and the countries that sticks out at the top right are the largest net importer also listed in the table. These are not necessarily the countries that produce less. In fact, several net importing countries are also major producers. China, for example, is one of the top net importer in 2025, but it also supplies large amount of footprint through its export. Among the G7 countries, 4 countries are top net importers of footprint, while only Canada is top net exporter. For example, United Kingdom, France, Japan, and Italy in 2025 had a larger import of carbon-intensive commodities like petroleum products, crude oil, and gasoline. Countries on the left side of the graph are the net footprint exporters. A country's footprint of production does not always reflect the demand of its resident. Rather, it also includes the demand from the rest of the world. So on the left side, the countries sticking out at the bottom are the major net exporters. For example, Russia Federation supplies emission-intensive commodities like fossil fuel and metals. Similarly, Brazil in 2025 had higher footprint associated with the export of crops like soybean and maize, which are used in the global food and livestock feed. The countries with the thin line in the graph are more balanced, meaning their production and consumption footprints are closer in size. This distinction shows how trade can shift responsibility and pressure across borders. Now, after looking at the global picture and the country-level trade distribution, let's focus on one country that stands out. This graph shows China's net footprint of import from 1961 to 2025. China is one of the major producers in the world, but from a footprint perspective, it is still a major net importer. At first, that may sound counterintuitive. We often think of China as a country that produces goods for the rest of the world. And that is true. In fact, China had largest export in terms of footprint from 2011 to 2023. But this graph shows different side of the story. It shows that footprint China import is larger than it produces. In the early part of timeline, China's net import was relatively very small. But from 1990s, the line began to rise more strongly. From 2000s, that's when China's integration in world trade, the line became more pronounced, except for the recession in 2007 and 2008. During the pandemic as well, China was offshoring its footprint, but in later year in 2022 and 2023, its net import slightly declined. That's when global economy was recovering and the demand was also less. China is not only producing for the world, it is also drawing on world's biocapacity to support its own consumption and industrial system through import of raw materials and intermediate goods. When we look into the composition of trade, crops like soybean, wheat, maize appears to be major part of China's imported footprint, which are again used in the food and as a feed in livestock production. In 2025 alone, China's footprint of net import of soybean was 97 million global hectares, which is equivalent to 62% of global soybean import. To put this in area context, we need cropland roughly 26 times the area of Bhutan to meet net demand of soybean of China. And of course, it will change on the per capita basis. With this large population, the per person demand will be 0.06 hectares. Footprint moves across border through trade, but commodities helps us understand what is moving through that trade. So with that, I will pass it to Bumika to talk about commodity detail capture in our account.
Thanks, Neha. So now shifting our focus to the micro level data. To generate each new edition of these national accounts, we use updated data sets from a variety of reputable and official sources for emissions, production, and as well as trade data. And a lot of our data comes from the United Nations, particularly the UN FAO, aka the Food and Agriculture Organization of the United Nations, as well as other data sources like the International Energy Agency, as well as Sea Around Us. And to showcase the breadth of the data that we have in our database, The table on the screen shows the number of sectors, products, commodities, as well as species that we have data on, like the over 2,300 aquatic species we have under fishing grounds, and the 420 crop-derived products under cropland, all totaling to over 91 million rows of data. And these microdata are then used to generate the accounts for the 6 components of the ecological footprint that we then apply in the national accounts. To illustrate the level of data that we have captured in the crop trade data, all 420 crop products covered in the National Ecological Footprint and Biocapacity accounts are listed on the screen. And this breadth of coverage is really important because it shows that the analysis isn't limited to a small group of major or high-profile commodities, but instead reflects a much more comprehensive representation of crop trade flows across the globe, as well as our database. So to highlight diverging commodity trends, we decided to profile 2 different commodities. And the first being oil, and not the oil that's been in the news lately on the Strait, but oil crops. And so we're focusing on the ones with the largest ecological footprint of production over a time period of 1961 to 2023. And this first graph here shows the top 5 oil crops by global ecological footprint of production, with rapeseed emerging as the dominant oil crop from 1987 and onwards, exceeding over 100 million global hectares of cropland, while other leading oil crops like sunflower seed and palm oil fruit remain roughly below 80 million global hectares. Now, focusing on rapeseed, the top oilseed crop by global ecological footprint of production, we can analyze the data to understand who the main producers of rapeseed oil are in terms of ecological footprint. And in our accounts, Canada, China, India, and India, colored in red, yellow, and green, are the top producers of rapeseed oil, representing over 50% of global production between 1961 and 2023. And the rest of the world in blue reflect less than 50% of the global rapeseed ecological footprint of production. Now that we've learned that rapeseed production is concentrated among those 3 major producers, we're going to zoom in to the trade of rapeseed. So what does it look like when we compare each country's imports to their exports? Or in other words, the ecological footprint of imports minus the ecological footprint of exports to get the net imports of all of the countries. And so the countries on the right in blue are the net importers, while the countries on the left in orange are the other net exporters. And as we can see, most rapeseed trade involves very few countries, and there are more net importers than net exporters. So overall, there are fewer countries carrying that export burden and accounting for those large net exports. So taking a closer look at the top 10 net importers and exporters of rapeseed, Germany, China, and Japan are the top net importers. And Germany's position as an importer is very closely tied to its biodiesel industry, where rapeseed remains the dominant feedstock. And Japan, by contrast, is much more dependent on imports due to its limitations in domestic production. But the most interesting case here is China, where despite being one of the world's largest rapeseed and rapeseed oil producers, it still appears as a top net importer, indicating that it actually imports more than it exports. And to add more context, we supplemented the trade balance graph with the percentage or share of consumption supplied by imports, measured as the ecological footprint of imports relative to the ecological footprint of consumption. And this basically shows not just whether a country is a net importer, but also how dependent their domestic consumption is on foreign supply or imports. And China is a good example of this, where although it was one of the largest net importers of rapeseed, considering that it has a large domestic production, it actually only relies on imports for about 1/4 or a quarter of its rapeseed consumption. Whereas countries like Japan, Mexico, and Austria, which is last on the table of top importers, rely heavily on imported rapeseed for domestic consumption needs. And then lastly, just a quick note on Belgium there. You might be wondering why its consumption supplied by imports is over 170%. And that's because it also actually re-exports 40% of its imports, meaning its import flows exceed the actual footprint of its final domestic consumption. Finally, we also, as our second commodity, we investigated newsprint, where a declining trend was observed for the ecological footprint of newsprint consumption in the 23 years since the year 2000. And as you can see, the countries started at very different levels of ecological footprint of consumption, with the USA at over 30 million global hectares in the year 2000, and Canada being well under 5 million around the same time. But ultimately, all countries experienced a stark decline and converged to a very similar amount of level of ecological footprint in recent years with the rise of digital media, among other important factors. And so with that, I will now pass it off to Anne to talk about methodological improvements.
Thank you, Bumika. We're always working on updating our workflows and data sources to improve on the accuracy of the accounts. And every year we recalculate the entire timeline of ecological footprints and biocapacity going back to 1961. The graph on the screen shows the ecological footprint of consumption for the world in last year's edition, the dotted line, and the current edition in yellow. Over the entire timeline, the ecological footprint of consumption is lower than the last year's edition. The difference is most pronounced in the recent years. I will walk you through some of the key changes that we made in this edition compared to last year's edition that explain these differences. For the first time, we're using the Global Human Settlement Layer, GHSL, as a source for the built-up component of both ecological footprint and biocapacity. Specifically, we're using the degree of urbanization, which further distinguishes built-up areas by their proportion of density and has 6 data years, from 1980 to 2025. Previous editions relied on data sets that had fewer data years or only covered the 21st century. This new source gives us a much sharper picture of how human settlements have changed over time and how it has affected results in 220 countries over the entire timeline. The second major difference can be found in the forest carbon uptake element of the ecological footprint. The new release of one of our data sources, the Global Carbon Budget, incorporates new evidence and process understandings of global carbon emissions and sinks. In the newest report, ocean carbon uptake is increased when compared to the version we used in last year's edition. Because the ocean absorbs more carbon than was previously accounted for, there is a lower need for carbon offsets by the forest carbon sequestration. This affects every country's ecological footprint all the way back to 1961. Other differences come from our use of the International Monetary Fund and World Bank data on traded total volume for the most recent years to fill the timeline where our main commodity-based UN Comtrade figures lag behind. We refined the way that the accounts included unreported fish landings and discards with data from the sea around us. And finally, we broadened our forest products accounting to include recovered paper and fiber pulp, which affected ecological footprint embodied within traded forest products and therefore national consumption of forest products over the entire timeline. Of course, full methodological details on all changes are documented in the release notes accompanying this edition. So you're welcome to look them up. On top of these changes, we're also having ongoing research. So I'll now hand it over to Petra to tell you about her research.
Thank you, Anne. We are constantly, as Anne mentioned, improving on the methodology. And just one example of this work comes from my master's project, which focuses on integrating wetlands as a land component in biocapacity. In my research, I use global datasets on wetland area and productivity to build national estimates for Iceland, Sweden, and Germany from 1961 to the present in an accessible and replicable manner, which was designed to be fit for integration for further countries national accounts are published for. Once again, this is just one example of the many ongoing research projects, and there are many opportunities and applications that can be developed from engaging with our data. You can download our data from our website, footprint.info.yourq.ca, and on the website you can find national and world total data as an Excel workbook, as well as the release notes with details on metadata and methodological changes made since the previous edition. The Excel workbook contains data on the ecological footprint and biocapacity for 244 countries and territories, as well as the world total. We are looking forward to seeing the applications develop with the data, and in case you have any questions, you can always reach out to us at footprint@yourq.ca. You are welcome to make a request for detailed data in case you are researching a specific commodity. For example, earlier Bumika presented the ecological footprint for rapeseed oil, which she used to differentiate between countries based on their share of global production, import, and exports. Commodity level data is not included in the Excel workbook, but is freely available upon request. So please reach out to us with your data needs. And now Neha will jump into some further opportunities to use the data in combination with other metrics.
Thank you, Petra. To build on the idea of engaging with footprint data, I also want to highlight that our data can be used along with the range of socioeconomic and environmental indicators. It can be used to compare, complement, and add ecological footprint context to these indicators. For example, the Happy Planet Index uses ecological footprint data as one of its metrics to measure how well nations are doing at achieving sustainable well-being. So this graph provides a very simple example of how our footprint data can be used along with life satisfaction data, which was taken from World Happiness Report. The purpose is not to suggest that the ecological footprint alone determines happiness, but to place reported life satisfaction in context of ecological demand. Here, in the x-axis, it shows per capita footprint of consumption, which is measured in global hectares, and in y-axis shows life satisfaction from the World Happiness Report. Each country's position shows how life satisfaction relates to the footprint consumed per person for year 2025. The orange, or the happiest countries, are mostly concentrated in the upper left corner. As you can see, they have achieved high life satisfaction without being at the extreme end of footprint. Costa Rica is an interesting example. It ranks very high in life satisfaction with a very much lower per capita footprint than countries such as United States or Canada. In 2025, even though Costa Rica's per capita demand on nature was 2.5 times less than Canada, its life satisfaction was 1 unit more than Canada. The blue countries saw a more uneven pattern. Some countries with high per capita footprint, such as Iceland and Luxembourg, also report high life satisfaction. But others have high footprint without reaching same life satisfaction level as several of the happiest countries. When we compare the footprint per capita rank along with their happiness rank, then in 2025, Mongolia was ranked as 5th in per capita footprint but ranks 75th in the happiness rank. The United States ranks 6th in the per capita footprint but only 23rd in the happiness rank. Canada's per capita demand was 6.6 global hectare, which was larger than most of the world's top 10 happiest nations from 2025. Yet it ranked 25th in happiness rank. Now, this is a very interesting coincidence that countries with higher per capita footprint may not necessarily be the happiest. Now, moving on to the different example, this graph compares how countries' efficiency changed between 2015 and 2025. Here, efficiency is measured as life satisfaction per unit of footprint per capita. Since this is a ratio which can be influenced by changes in life satisfaction, changes in per capita consumption, or changes in both at the same time. This chart shows the ratio change from 2015 to 2025. On the right side of the chart, with the green bars, represent the countries where efficiency improved, meaning they generated more life satisfaction per unit per capita footprint in 2025 compared to 2015. On the left, with the red bar, represents the country that saw a decline in their efficiency, meaning the countries became less efficient in converting resource demand into reported life satisfaction compared to 2015. The highlighted bar in different colors are among the top countries with higher per capita footprint in 2025. It was observed that the countries with significant efficiency gains were not necessarily among the countries with the highest per capita footprint. For example, Laos saw one of the strongest improvement with its efficiency improved by 104%. On the left side are the countries that saw decline in efficiency in a decade. For example, Afghanistan per capita footprint declined slightly. However, the reported life satisfaction declined much more sharply. So since both indicators showed decline in the same direction but was more sharper than others, so Afghanistan life efficiency declined compared to 2015. Among the high footprint countries, the United States and Canada shows efficiency gain of 8% and 6%. Even though both of these countries saw decline in life satisfaction and their per capita consumption of footprint in 2025 compared to 2015, they gain efficiency. Again, this chart does not intend to imply a direct relationship between per capita footprint and efficiency change. Rather, this is one example of how footprint can be engaged with other metrics. When paired with indicators such as life satisfaction, it helps compare not only how much demand are on nature, but also what social outcomes are achieved relative to that demand. And with this, I would like to pass it to Kiona to talk about IFIL and its partner.
Thanks, Neha. So behind these accounts and the analysis that we have presented is our team of analysts. So I want to take this moment to acknowledge everyone who made this edition possible, and also to highlight the diversity of our team. Our analysts were born across 3 continents, and you can see that reflected on the map. Our institutional homes are in Canada and in Iceland. Both are highlighted in blue on the map as well. And this national accounts are also embedded in a broader partnership that Eric mentioned in the beginning, IFO, which is also known as the International Ecological Footprint Learning Lab. Key partners being York University, University of Iceland, British Columbia Institute of Technology, and the Global Footprint Networks. So this partnership brings together both academic and non-academic partners from across the world to advance training, research, and practice in ecological footprint and biocapacity accounting. This partnership is funded by the Canada Social Science and Humanities Research Council. And I'd also like to take this chance to acknowledge our partners, which is reflected in this next map on the screen. Yeah. By the orange pins. We are incredibly proud and grateful to work with our partners. And lastly, I want to showcase some examples of the work that we have done under this IFO partnership. So if we go on to the next slide, we will see some examples of the work. So with the Rural Ontario Institute, we've calculated ecological footprint and biocapacity for over 500 municipalities across Ontario. And likewise, we've also done city-level footprint work in Vancouver and also in Reykjavik as well. And in Sri Lanka, we've been supporting footprint accounting at the university level, which is modeled what we have done at York University. So if any of this works or our presentation resonates with you, whether you're a researcher, a student, or part of an organization looking to apply footprint accounting, we'd love to hear more from you. There's opportunities to join the Learning Lab as a partner, collaborator, or as a student. So with this, we want to conclude the launch of the 2026 edition of the National Ecological Footprint and Biocapacity Accounts.